now we're going to talk about cell form and function and how a cell's environment and function can affect its form. So we're going to look at some examples just to kind of see how this works out. The first example we're going to look at is nerve cells. And I've drawn a nerve cell here to the left. And the function of nerve cells is to relay signals throughout the body or organism. Now the form of the nerve cell, we can see it has the long extension of the nerve fiber to send signals, and lots of signal receptors at the body of the cell. So this is the cell body. And that nerve fiber can get very long. There's a nerve in giraffes that actually runs all the way up the neck of the giraffe. So that's really long. So you can see how the nerve cell does very good at its function because its form is fitted for that function. Another example of how the form is fitted for the function is for intestinal cells. And intestinal cells have a function to absorb nutrients and the form with microvilli increase the surface area. Therefore, the form increases efficiency, essentially. I'll draw a little nucleus in the cell, make it a little more legitimate looking. The next type of cell we're going to look at is skin cells. And skin cells are supposed to protect and act as a barrier and the form of being flat and plate-like, having many layers, also increases the efficiency that it can do its job. And we can think about this a lot because if you scrape your arm or something, you don't always necessarily get hurt or bleed, but what you've done is you've scraped off some layers of cells probably. But because there's so many layers, you're protected from injury because of that function or the form they have of being layered. And lastly, we're going to look at red blood cells. And it's not as obvious why their form fits their function, but looking at a red blood cell, we know their function is to deliver oxygen to body cells. So one of the main functions is to deliver oxygen, and its form has no nucleus. The nucleus is removed from red blood cells as it exits the bone marrow. So this doesn't seem like it really would be a benefit, but that leads to the dimpled shape, which increases its efficiency and surface area to deliver oxygen better. Will deliver and even absorb. It's going to be very important to be able to absorb the oxygen as well, because it's got to get that from the lungs. So the better it is at that, the better it is all around. So these are a bunch of examples of how body cells can have their forms match their functions very well, and their environments also. So like the red blood cells also are of a shape that won't get stuck per se in arteries and veins as well as they might be if they were square, something like that. So that's all about cell form and function.